Assalamualaikum warahmatullahi wabarakatuh and good morning to all my students. Today I'm going to give a lecture or explanation of the topic 7 according to your lecture notes. So we're now in lecture 2 of 6, 7.1 probability. Okay, this topic which is something that related to our daily life. Okay, so without wasting so much time, let's continue. Okay, so at the end of the lesson, okay, students should be able to find the probabilities of the intersection and union of two events. So probability of two events A and B occurring can be calculated using additional probability rules such as below here. Okay, so class, in this case, if I give you an example of one diagram, okay, where this is a set element of A, event of A, and another one, event of B. Okay, so if you look at this area, there is a we call redundant between event A and event B. So if look at this one here now, probability of event A, meaning we call everything that related to the event A, and then probability of event B, which means that everything or element that related in event B. Okay, so now, what can you see in this area? Okay, what can you see in this area? We can see that we call this shade color of blue and the purple, meaning in this area, we count it twice. Okay, we count it twice. So in that case, we only want this area, and this area, we count it once only. So that's why we come up with minus of probability of A intersect B. So from here, okay, just now when I mentioned here, saying that in this area, we count it twice. So once we minus with probability of A intersect B, then we count it in this area. We count it is in this area once only. Okay, so this is the formula of A union B equal to probability of A plus probability of B minus probability of A intersect B. If there's we call a redundant between event A and B, and we want it to count it once only. Okay, in a class of 30 students, 5 out of 20 girls and 7 out of 10 boys are members of the Mathematics Society. A student is selected randomly, so what is the probability that the student is a girl or a Mathematics Society? Okay, so then, so let G, the event of being of a girl being selected, and the event of a student selected being a member of the Mathematics Society. Okay, class. Before we look into the event of G and M, let's take a look at this. They are all 30 students. And 20 girls. So out of 30 students, 20 are girls, so then 10 boys. Okay. And then 5 out of 20 are members of Mathematics Society. Okay, Mathematics Society, from 20 girls, 5 of them are members of Mathematics Society, and for boys, 7. So means that the total of students, boys and girls, who join the Mathematics Society here now are 12 of them. Okay, so in this case, if I come up with this, we call, let's say this is event of boy and girl. So, and then 5 out of 20 girls. So there are all 20 girls, 5 of them here. So then 5 plus something equal to 20. So 5 plus 15 equal to 20. And then 7 out of 10 boys are members of mathematics. So 7 here. And then 7 plus something equal to 10. Yes, 7 plus 3 equal to 10. So in this area, redundant area, where the boys and girls are members of mathematics society, 5 plus 7 equal to, yes, 12. Okay. So now, let G, the event of girl being selected, and M, a member of students, the event of students selected being a member of mathematics society. So then, first one here, probability of girls, which is 20 out of 30. And probability of the students joining the mathematics society just now, which is 7 boys and 5 girls. They are all 12 out of 30, the number of the students. So, probability of G, the girls, intersect with M. Okay, probability of G intersect M equal to, okay guys, girls, what's the meaning of this? Probability of girls intersect M, meaning probability of the girls who join the mathematics society. Okay, so as I recall, sketch the diagram just now. This is boys and girls. Girls are all 20, which is 5 joining mathematics and 15 are not joining mathematics. And the boys, 7 joins mathematics and the rest, which is 3, are not joining mathematics. Okay. So here, what we call girls that joining mathematics, which I think that is not suitable for me to using this diagram. Let's see if we can use the table. I think that that's we call one that's suitable compared to the previous then just now. Okay. Okay, so boys and girls joining mathematics and did not join mathematics. So the total of all the students are 30. So the total of boys is 10, the total of girls is 20, and the total of girls joining mathematics, which is 5, and that does not join mathematics is 15. And here joining mathematics 7 and did not join the 3. 7 plus 5 equal to 12 and 3 plus 15 equal to 18. So look at this one. 10 plus 20 equal to 30. 12 plus 8, 12 plus 18 also equal to 30. So probability of G intersect M means that the girls joining mathematics program society here, which is 5 out of 30. Okay, so now probability of G O M. Okay, the probability of girls, which is overall is 20, union M. M means that the total of students joining mathematics society, 7 plus 5 equal to 12. So then, there are 20 over 30 plus, okay, girls, 20 of them, plus with mathematics, joining mathematics, 12. 12 out of 30 minus G, we call intersect M, which is 5 over 30. So, 20 plus 12, 32, minus 5 equal to 27 over 30, which is equal to 9 out of 10. Okay. That's it. An integer, okay, example 2, an integer is selected randomly from a set of integers, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Find the probability that the integer is even number or divisible by 3, meaning that even number, probability of even number, which is 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is, this is all the the element of even number, and the total here 6 out of 12, which is 1 over 2. Or divisible by 3, probability of divisible by 3. Okay, so divisible by 3, 3, 6, 9, 12. There are 4 of them, 4 out of 12. Okay, so then, for the first one in here, okay, probability of even union divisible by 3, which is probability of even number plus probability of divisible by 3 minus probability of even number intersect with divisible by 3. Okay, so now, what is the probability of even numbers that intersect with divisible by 3? Okay, so divisible by 3, we have 3, 6, 9, 12. So even numbers intersect with divisible by 3. We have 3. Do we have 3 here? Nope. 6? Yes. Okay. 9? No, because it's an even number. Or 12? Yes. So 2 out of 12. So then probability of even number 6 out of 12 plus with divisible by 3, which is 4 out of 12, minus even number intersect with divisible by 3, 2 out of 12. So 6 plus 4 equal to 10, minus 2 equal to 8 out of 12, or 2 over 3. Okay, and okay, this is all the solution of question A. And right now, let's continue with question B, which I think that I'm going to use the same page here so that we can refer to the questions and straightly we answer the questions here. Okay, because this video is being recorded, so you can just simply rewind, pause, forward, play, stop. Okay, just like we call, just the way you need it. Okay, so now the event probability the event is an even number. Even number, probability of even number, which is 2, 4, 6, 8, 10, 12. There are 6 of them, 6 out of 12. And not divisible by 3. Okay. Okay, class. So let's say if this is the probability of the numbers that can be divisible by 3 just now, 3, 6, 9, 12. There are 4 of them. 4 out of 12. So then, probability of the numbers that cannot be divisible by 3. Oh, sorry, not TE. D3, supposedly, sorry. Okay, this is a probability of numbers that can be divided by 3. So, the numbers that cannot be divided by 3, okay, which is 1 minus 4 out of 12. So, just imagine that this is 12 out of 12. 12 minus 4 equal to 8 out of 12. Okay, 1 cannot be divided by 3, 2 cannot be divided by 3, 4, 5, 7 cannot be divided by 3, 8 cannot be divided by 3. So then, all the numbers except this one here, which is 3, 6, 9, and 12. So now, an even number that n is not divisible by 3. What is the property of even number? And it is not divisible by 3. Okay, so here, even numbers 2, 4, 6, 8, 10, and 12. Okay, the numbers that is not divisible by 3, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's compare the numbers which is not divisible by 3, 1, 2, 3, 4, 5, 6, 7, 8, these numbers, and the numbers that even numbers. We have 2 here, 4, 6, nope, okay, 8, yes, 10, yes, 11, nope. So 1, 2, 3, 4. So probability of even number and not divisible by 3, which is 4 of them. 1, 2, 3, 4. Okay. All class. Okay. So there's another way of this for looking at find the answer of this. Probability of even number, which is recall intersect with the numbers that cannot be divisible by 3 here. So then it is we call probability of even number minus probability of even number that which is intersect with the numbers that can be divisible by 3. Okay, so then this is 6 out of 12. 1, 2, 3, 4, 5, 6 minus a numbers that can be divisible by 3, which is also even numbers, 6. Okay, 6 and 12. Okay, even numbers that can be divide by 3, which is 2 out of 12 equal to 4 out of 12 or 1 over 3. There you go. Okay, this is a solution for question B. Okay, next. Okay, find the probability that it's not an even number and not divisible by 3. Probability of not even number. Not even number means that it's an odd, which is we have probability of even number. We have 2, 4, 6, 8, 10, 12. There are 6 of them. So 6 out of 12. So this one here, which is 1 minus 6 out of 12, also equal to 6 out of 12 because it is 12 minus 6. Okay, and it is not divisible by 3. Probability of the numbers that cannot be divisible by 3. Okay. Okay, for this one here now, class, if you like to find the probability of not even number, and then it's not a numbers that divisible by 3, we can just simply 1 minus probability of even number union and numbers that divisible by 3. If I'm not mistaken, then in the question solution of A just now, I'm using probability of A union B, or might be something like this. So it is 1 minus probability. What is the answer of the question A just now? The solution of A just now your even number union with numbers that they divisible by 3? It is 2 out of 3, right? Okay, 2 over 3. So 1 minus 2 over 3 equal to 1 over 3. Okay. So let's take a look. Let's go to the next example. Okay. Sometimes this kind of question, okay, information is also given in table form. The value of probability is defined based on that information. So A, B, C, D are 4 events that can be written in the table below. Okay. This is event A and event B. Then we have C and D. So this intersect between A. Okay, probability of A intersect with C. So A and C, will they meet here? And this one is probability of A intersect D, where A intersect with the event of D. Okay, so the total of this, it will give you the probability of A, event A. Okay, it might be not clear with this table. Let's go to the next question. Okay, a survey is conducted on a group of workers comprising of production operators, administrative officers, and security guards. The survey is to determine the total working hours in a week. Okay, for those working less than 40 hours a week, okay, so these are the numbers according to their job, then here, okay, and then 50 to 70, and then more than 17 hours. So then right now, one of the workers is surveyed randomly selected based on the information provided, calculate the probability of workers being a production operator, working in all this. Okay, so now let B the worker of production operator, A the worker is an admin, as a security guard. Okay. Okay, so let's rewind. Okay, so now, okay, because the question and every pages is different here. Okay, the first one. Okay, before that, let's count out the total of the staff here. 8 plus 2 equal to 10, 0. 8 plus 1 equal to 9, 9, 7 equal to 16, plus 1 equal to 17. So then 1 plus 1 equal to, so the total of the workers here is all 270 of them. So now the first one then, worker being a production operator. Okay, so for this, the first one then, the question A, workers being a production operator, being a production operator, which is, okay, so they're all 196, okay, because production operator, the total of these are 196, divide by overall, the overall or the total of the staff, which is 270. Divide by 270. Okay, and then next, workers who work between 50 to 70 hours. Okay, workers working between 50 to 70 hours. Okay, 50 to 70 hours, they are all, okay, 46 plus 14 plus 10, which is equal to 70. And then the total out of, recall, the workers there, 88 plus 70 plus 112, equal, which is 70 out of 270. Okay, the total of workers, what you call, working 50 to 70 hours, which is equal to 70 of them divided by the total of the staff, which is 88 plus 70 plus 20, 112, equal to 70 out of 270, which is 7 out of 27. Okay, question C. Question C, workers admin and work more than 17 hours. Probability of admin and work more 70 hours. Okay, so in this case, admin working more than 70 hours. Okay, the administrator's officer, the total is 43. Okay, no, it's not that. Okay, the question said the work we call administrators that working more than 70 hours. So admin and working more than 17 hours, and the total of them are 8 out of 270 workers. Okay, which is 8 out of 270 or 4 out of 135. And question D. Question D. Worker being a security working less than 40 hours. Okay, now security working less than 40 hours, which is 4 out of 270 staff. So then, probability of security working less than 40 hours equal to 4 out of total of the staff, which is 270, or 2 over 135. Okay. So, mutually exclusive event are called, two events A and B are called mutually exclusive if they cannot occur at the same time. Neither event A nor event B can occur simultaneously. Thus, the probability of A and B occurring at the same time is equal to 0. Okay, meaning that at one time, if A appear, B will not appear. Only one. Okay, there is no intersection. So then we can make simplify this explanation by this Venn diagram where A and B. Do you find any intersection between A and B? Redundant area? No. Okay. The previous diagram, it shows that A and B, and there's an area where they occur at the same time. But here, there is no appearance of A and B at the same time. Okay. So now, probability of A union B equal to probability of A plus probability of B. So then, two concepts of mutually exclusive can be extended to more than 2 events here. Okay. So C and D are 2 events where probability of C equal to 0.1, probability of D equal to 0.2, and probability of C union D equal to 0.3. So determine whether C and D are 2 mutually exclusive events, and then probability of C complement, before that. Probability of C equal to 0.1. then probability of C complement equal to 1 minus 0.1, which is 0.9. Probability of D equal to 0.2, then probability of D complement equal to 1 minus 0.2, which is equal to 0.8. Okay, now, the first question, whether C and D are two mutually exclusive events. Okay, probability of A union B equal to, okay, C, okay, probability of, okay, they're using A, C, and D, not A and B, sorry. Okay, given that probability of C union D equal to 0.3, and let's double check with probability of C plus probability of D, which is 0.1 plus 0.2 equal to 0.3. So probability of C plus probability of D, 0.3. Probability of C union D equal to 0.3. So then, when probability of C union D equal to probability of C plus probability of D, so then C and D are two mutually exclusive events. Okay, that is a solution for question A. And now, find probability of C complement and C complement intersect with D complement. So probability of C complement, okay, equal to 1 minus probability of C, 1 minus 0.1 equal to 0.9. There you go. Okay, then probability of C intersect with D complement. If there are two mutually exclusive events using Venn diagram, let's say this is C and this is event of D. So C complement means that everything which is not C. So they are all outside. Okay, which is not C. And then D complement, which is not D. Okay, class. Now, okay, which is not D. Not D means that including C here. Okay. So my question to all of you, C complement intersect with D complement, which I think that intersect means that they recall redundant or meet the blue line and the red meet each other. Do you find any blue and red line meet in this circle of C? No, it's only red, right? And do you find any red circle in this this circle of D here? No, it's only the blue line. Okay, the blue shade. So outside of C, outside of D is where you can find the blue shaded and the red shaded meet each other. So probability of C intersect D complement, which is 1 minus probability of C, okay, C union D, sorry. Union D. 1 minus, okay, probability of C union D, which is 0.3 here. So 1 minus 0.3 equal to 0.7. Okay. So class, this is an exercise. I leave it to all of you just to try and see whether we can get the answers or not. Okay. And the final answers is provided here. So just test yourself. Exercise number 1 and exercise number 2. Okay. In this case, question A is 11 over 75. And question B is taking chemistry. The final answer is 39 over 75. So that's all for today. Thank you very much for join my lecture videos here. Till we meet again, and hopefully that this video benefit to all of you. Good luck in your revision and examination. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.